In this video, we're going to be simplifying rational expressions. In order to do that, we need to think back to pretty much all of our factoring methods, and also think about what we're allowed to cancel on top and bottom of a fraction. So real quick, let's look at a generic little rational expression here. Because top and bottom, because of the numerator and denominator, both have the same term, well, something divided by itself is always 1. So really, we can factor that out or just get rid of it. But remember that dividing something by itself is not 0, or it doesn't disappear. Dividing something by itself is always 1. So in a case where, let's say we canceled the only term on the top, it doesn't just go away, it becomes 1. So then we would have 1 over a. Alright, so let's get into it. Again, we're going to be practicing a lot of variety of factoring methods in this video. GCF, factoring out the greatest common factor, is one method. We're going to use that right here. If we look at these two terms on top, they both have an x in common, so let's factor out an x. And rewrite what's left over inside the parentheses. If we distribute here, we should get back to the beginning. It's always a good way of checking to make sure that you factored correctly. And then on the bottom, x squared is the same as x times x. Because top and bottom both have x's, we can get rid of them and rewrite our simplified expression. Right here, I want to focus on something that a lot of people make mistakes with. So here we were allowed to cancel our x's because both of them were being multiplied. Here we're not allowed to cancel these x's because this x is being added. The only time we're able to simplify and cancel a common factor is if it's being multiplied. If it's being added or subtracted, we are not allowed to cancel it. So this is our final answer. Let's do another one. In this example, we see a couple more different factoring patterns or methods. Up top, we could use what I like to call an x factor. If we think about factors of our last term that add up to the middle term, then we can factor that polynomial. So factors of negative 12 that add up to negative 4. I can think of 6 and 2. And each parenthesis is going to get the variable that's in our problem. So now the trick here is what sign goes where. If I want them to add to negative 4, that means that I need a bigger negative number when I combine them. And if I multiply these two, I get negative 12. So x minus 6 times the quantity of x plus 2 is the factored form. On the bottom, we have another special factoring pattern here. This is called a difference of squares. Each term is a perfect square. We write the square root in each parenthesis of the first term and the square root of the second term in each parenthesis. I like to put a negative in the first set of parentheses and a plus in the second set, although it doesn't really matter which one gets either of them. The reason I like to put the negative in the first one is because sometimes when you factor a difference of squares, you have another difference of squares. And if you put the negative first, it hopefully helps remind you to check that and to refactor. Because a sum of squares doesn't have a factoring pattern, only difference of squares. So now that we finally factored both top and bottom, we cancel common factors. X plus 2 is on both top and bottoms. We can just get rid of it, and our simplified expression is x minus 6 over x minus 2. Let's do another one. What happens when we are multiplying rational expressions here? There's one rational expression, and I'm going to multiply it by another one. Alright, so basically we can ignore the second one for now and just focus on the first one. Just factor and cancel any common factors. So let's see. They both have x's and they both have y's. So I'm going to factor out an xy from the top and bottom here. If I do that, that gives me 5x left over. And on the bottom, if I factor out an xy, that leaves me with 2y squared. And that way we're able to simplify before we multiply. And that generally makes our multiplication much easier. Now there's going to be several different methods we could actually simplify this expression here. This is just one way. Factor first, simplify, and then multiply. So what do top and bottom here have in common? They both have a 2 and they both have a y. So I'm going to take out 2y from the top and the bottom here. If I take out a 2y, I'm left with 3x to the third y. And on the bottom, I'm left with 5. So we cross out the common factors, and now we can multiply straight across if we want. Or we can do what's called cross-reducing, where we reduce diagonally here. Either one, because 5 is going to end up on the top, and this 5 is going to end up on the bottom, we can go ahead and cancel those. That would just equal 1. We don't have to multiply and divide by 5. Anything else that we have in common here on top and bottom? We have 1y here and 2 y's down there, so I could cancel this y, and then I'm left with 1y on the bottom. And now we can multiply with just the remaining terms that are left. So x times 3x cubed would be 3x to the fourth, and 2y is all we got on the bottom. Here's our final answer. Another way we could do this is multiply first. That's not the ideal way, but it's certainly possible. We could do 5 times 6, that's 30. X squared times x to the third is where we add our exponents, so we get x to the fifth. And y times y squared would be y to the third. On the bottom we would have 2 times 10, that's 20. X, there's no other x's, and y to the third times y would be y to the fourth. And then we could simplify from here. We could easily knock off the zeros here. Since we have 5 x's on top and 1 x on the bottom, we could cancel 1 from each and be left with 4. That's right there. And then we have 3 y's on top and 4 y's on the bottom being multiplied. We could cancel 3 from each and be left with 1 y on the bottom. So either way you like to do it, it's kind of up to you, it's your preference. Let's do another. What else do we got? More of the same here. Just getting more complicated polynomials being stacked up here. So again, we could multiply, but the more complicated things get, the less you want to multiply first. I mean, it really just makes it a lot harder. Factoring first and canceling common factors will always simplify your multiplication and in general make the problem a lot easier to solve, a lot faster, a lot less room required. So let's factor. Top here on the left side, we could factor out a 4x from each of those terms, and we'd be left with a 1 minus x. On the bottom, use your x factor method. We're thinking about factors of -3 that add up to +2. Well, we know we want a bigger positive number because when we add we want a positive left over. Each parenthesis is going to get an x. We want factors of 3, so 3 and 1. And if we made the 3 positive and the 1 negative, that would add up to +2 and multiply to -3. On the right side here, again another x factor. Factors of -6 that add up to +1. There's a little invisible 1 there. X and x go in each parenthesis. If we use a +3 and a -2, that multiplies to -6 but adds up to +1. And 4x we could leave as 4x because I'm going to end up canceling it right here. 4x divided by 4x becomes 1. I have an x plus 3 and an x plus 3. And then we got some leftovers here. Now you might be looking at this wondering if you could cancel it. Not right away. We want to make sure that each thing on top and bottom is exactly the same. If we factor something out here, well, if we rearrange it and then factor out, that might make more sense. I'm going to rewrite it. I'm going to say -x first, just so the x is in the front. And that might help us visualize a little better what I'm about to do here. So -x and a +1 there. How can I make this look like that? Well, if I factor out a -1 and rewrite the leftovers on the inside, I have a +x and I have a -1. And if I distribute, I would get back to -x plus 1. Well, now on top and bottom, I have the same thing. And I can cancel those out. So now I'm just multiplying this x minus 2 times -1. And we could leave it like this, or we could distribute that -1 all the way through and say -x plus 2. That's pretty much all the time I got. Just keep factoring your polynomials using any method you know how to do. The thing that I did not mention, one form that I did not mention is difference of cubes and sum of cubes factoring patterns, but you can look in previous videos on how to factor those. Yeah, good luck. Just remember to factor first, cancel common factors before you multiply, and that will simplify your problem altogether there.